Welcome to the third of our dedicated sessions dealing with Tekla Structural Designer integration with Tekla Structures. Within this session we will demonstrate the process of synchronization and managing model changes, both from Tekla Structural Designer to Tekla Structures, and from Tekla Structures through to Tekla Structural Designer. It is important to understand that synchronization can occur at any time, and a typical workflow may be to build the initial model in Tekla Structural Designer, and then perform the transfer into Tekla Structures. Once the initial transfer has been performed, then changes can be made either from Tekla Structural Designer into Tekla Structures, or out from Tekla Structures and into Tekla Structural Designer. There are no limits to the amount of changes which can be made or handled at any one time, and consecutive alterations can be provided as often as desired. Please note that the initial model transfer may have been made from Tekla Structures into Tekla Structural Designer, but the overall process would have been exactly the same. When tracking changes made to the model in Tekla Structures, please note that the software can track these changes in two distinct ways. Alterations can be reported either through the use of the model comparison tool, where detailed changes are reported in depth, or changed parts can be quickly identified through the use of color-coded representation views. This view representation can be used to identify all parts which have been added, updated or have been unaffected by the most recent model merge process. The model import dialog allows users to check and confirm changes made to existing models on an individual part-by-part basis. Details are provided on separate tabs for all new objects, all updated objects, deleted objects and unchanged objects. These changes can be checked and confirmed on a part-by-part basis, although there are also global options to ignore all deleted items, new items and so on. To show the model comparison tool, we have an existing Tekla Structures model into which we will import a new CXL file. We are expecting this new file to generate a second floor, replace the bracing patterns in the side of the building, and also extend the columns, but let's see how the model comparison tool works through the details. To import the second CXL file, we use the command Tekla Structural Designer, import from, which is available through the file drop-down menu. In the import dialog, we set the correct file name and location and can also preview conversions to ensure that there will be no mapping problems. After we have checked and verified this information, we can use the import at origin command to complete this stage of the import. The processing of the file now commences, and as the program detects that we are performing an update to an existing model, it shows a new dialog, the model comparison tool. The model comparison tool groups parts together according to the integration status, detecting items which are new, updated, have been deleted or are unchanged. These groups are shown on separate tabs at the top left of the dialog. Firstly, on the New tab, you can see that 17 items are going to be created as part of the import. The information on the right-hand side displays the coordinates, section profile, material, orientation and rotation of each of the parts. The Updated tab similarly shows each of the members which are to be updated by the merge process. The difference here though is that the existing original information for the part is shown on the right-hand side, as well as the new updated value for each of the parameters. Where values have been changed such as the profile name, or the coordinate values, you can see that these values are shown in red. To help identify alterations, there is also a checkbox option near to the bottom of the dialog to only display changed fields. The Deleted tab shows the 4 bracing members which are to be deleted by the merge process, and replaced with new items in this case. As we click on each entry, you may also notice that the object is shown on the model in the background. The Unchanged tab simply lists all members which are totally unaffected by the merge process. These parts will not be changed in any way by this particular import. You can see that we have global options to the bottom of the dialog. One of these is to ignore the deleted list, so that these items will be retained during the merge process. This option works as a toggle so the status changes as we enable or disable the option. Similarly, there is a global option to ignore all new items. As it suggests, once enabled it grays out the entire list of new objects and will not create these on import. Once we have done reviewing and potentially changing this information though, we can click on the Accept button, and the merge process will complete before returning us back to the basic import dialog. One of the shared parameters transferred from Tekla Structural Designer to Tekla Structures is the TSD integration status parameter, which indicates members newly created, updated and unchanged on the last integration process. We have created a view representation filter to color parts based on the TSD integration status parameter. This will allow you to easily identify members which have been integrated. To show the Tekla integration status representation view, we return to our earlier merged model. Within this model, we have items which have been newly created, updated and unchanged by the latest merge process. We access the Properties dialog of the view, and click to select the correct representation. This will be TSD integration status, and is at the bottom of this particular listing. We can then modify the view, to show the correct section coloring based on the integration status. Clicking on the representation button will show the representation coloring in more detail. Here we can see that new items are colored dark green in the view, and relate to the beams on the top floor along with the 4 side bracing members. Updated members are colored as light yellow, and in our case relate to the column members which were changed in section profile and span height. Unchanged items are the dark red colored objects, and these are the unaffected beam parts on the first floor level. We can now click OK to leave the various dialogues, and use the same view representation within the model view. The BIM status view can be used to track altered objects within the Tekla Structural Designer software. This command is located through the Review toolbar and simply color codes objects as to whether it has been newly created, imported from Tekla Structures, exported, updated or even deleted, and retained through personal choice during the merge process. Specific alterations can be tracked and highlighted within Tekla Structural Designer by interrogating the structural BIM import status. Individual alterations can be found by double-clicking on the reference to highlight the object. This is our example model in Tekla Structural Designer, which has been updated with changes from Revit. Once the processing of the model has finished, the changes can be seen in the status tree. Expand the structural BIM import references, and a list of alterations will be displayed. Changes can be displayed by double-clicking on each reference. All affected items can be identified by double-clicking on the parent entry. As an example, we can identify all members which have been altered in section size. Rebar information is transferred from Tekla Structural Designer into Tekla Structures. This can be viewed by inquiring on any concrete column or concrete beam part within Tekla Structures. This brings us to a close on this particular section. Our last part will cover advanced examples along with a full demonstration of the integration process. Thank you.